Certificates are not important in engineering and construction, skills and knowledge. Today we look at how you can accurately calculate the number of bags of cement in any project. So let's get into it. Hello everyone. Okay, today we are going to be looking at how you can accurately estimate the number of bags of cement in any structural member which you are about to pour, be it a beam, a pillar, a slab, or any other structural member. Okay. All right. So in this case, let's just take a slab. Let's take a slab or a floor. So let's say the length of this slab, let's say let's work in meters, it's 5 meters. And let's say the width is say 4 meters. And then of course we also need the height of the slab or the thickness. Also need this thickness. So let's say that thickness is 15 centimeters, or let's convert that to meters, 0.15 meters. Okay, so we need to have the volume of the slab, and that volume is going to be what we call the dry volume. Okay, because this is what you are going to have after you have actually done the pouring. So it means that the dry volume, which is denoted by the formula, the length multiplied by the width multiplied by the height, and here is the length 5 meters, the width is 4 meters, and the height here, or the thickness, is 0.15 meters. So that is equals to 5 multiplied by 4 by 0.15, and of course that gives us 3 meters cubed. Okay, all right, so this is the first way that we'll look at it. Watch till the end to see two other methods which are a bit easier and not as lengthy as this. Okay, so now we have the dry volume. Okay, so the dry volume which we have to pour is 3 meters cubed, as you can see here. But this is just the dry volume. Now let's say we are working, first we need to know the quality of the concrete which we are working with, the strength. So let's say we are working with, say, M20. Now this M20 is the quality of the concrete which we aim at pouring. So for M20, of course, you know that pouring this out, you need cement, which is always denoted as C. We need sand, we need aggregate, and we need water. So for M20, we have 1 bag of cement, and for the sand, we have 1.5, and for the aggregate, we have 3. Okay, so this, if we mix in this ratio, we are going to have the M20. Of course, we also mix with water, you know, and stuff like that. So let's calculate the weight volume. So to get the weight, okay, so like I explained, for the weight volume, now the first thing you have to understand is, let me just explain what the weight volume is actually. Now the weight volume is when you have mixed all these different elements in the proportion, of course, to give you whatever strength of concrete that you are looking at. In this case, we are looking at M20. And so these are the proportions which you have to mix in. So if we were to take 1 part of cement, 1.5 parts of sand, let's just say this is where you're mixing, and 3 parts of aggregate, and we mix this together, okay, we are going to be having a weight volume of this concrete. Okay, but now you have to understand that this is the value when it is already dry. So just by normal reasoning, you're going to see that when this dries out, it shrinks. Okay, it contracts, so it loses, it shrinks, so it is smaller than the weight volume. Okay, so with that in mind, you can easily calculate the weight volume. So the weight volume is always a certain ratio higher than the dry volume. Okay, all right, so for us to get the weight volume now, the weight volume of this concrete is always denoted as 1.54 multiplied by the dry volume, okay, of which in this case, the dry volume that we're working with is 3 meters cubed. Okay, and if we multiply that, we are going to be having, so that is equals to 4.62 meters cubed. And of course, you can see that it is greater than the dry volume because this is a product of the wet mix here, and this is a product of the dry mix. Okay, all right. Okay, so from here now, from this wet volume, we can now accurately calculate the number of bags, the volume of cement rather, the volume of cement that is actually going to get into this mix, and not from this. Okay, now this is a mistake that some people do. They always calculate from this, from the dry volume, but actually you have to calculate the volume from the wet volume. That is really to be accurate. Okay, all right. So for the third point now for the volume of cement, for the volume of cement that we're actually going to need here now, it's actually now going to be denoted by this wet volume which you have here, which is 4.62. Of course, that's meters cubed, divided by the proportion. Now, the proportion is going to be with respect to the grade of concrete that you are looking at, and in this case, we're working with M20, and you see the proportion up here: 1 part of cement, 2 parts of 1.5 parts of sand, and 3 parts of aggregate. So that is going to be divided by 1 plus 1.5 plus 3. And of course, we multiply this by 1, which is the ratio. Okay. Okay. So that is equals to 0.84 meters cubed. Okay. All right. So now, moving on, we know that the density of cement is equals to 1,440 kilogram per meters cubed. So what this means is, in 1 meters cubed, we have 1,440 kilograms. Okay. So in 0.84 meters cubed, we are going to be having what? So this is just cross multiplication. We have X, okay? So X now will be this, and the X, which is denoted now by the volume which we need in here, will be 1,440 multiplied by 0.84, and that is giving us and that gives us 1,209 kilograms. Okay, so how do we convert this now to number of bags of cement? It's very easy. Of course, you know that 1 bag of cement is 50 kilograms, right? One bag of cement is what? Is 50 kilograms, right? So 1,209 divided by 50 is going to give us something 192 kilograms, which is approximately 24 bags of cement. So it means that for this, in this case here, for this slab, we are going to need 24 bags of cement to accurately pour it. Now, of course, that is only because we are working with a grade of M20 and we are respecting the ratio. Okay, so if you were working with a higher grade, say maybe M25 or M30, of course, it's also going to vary. It will change because, of course, the ratio also changes. If you're working with a lower grade too, like say maybe M15 or stuff like that, it also changes accordingly. Okay, so that is how you get it. Now I'm going to show you two other easier ways of easily calculating this, but it's good to know this extended way, because you can actually use this in any scenario. But for a very easy and straightforward way of calculating it, we're going to look at that right now. Okay, so for another way of looking at this, which is still going to give us 24 bucks. Let's say we are still working with the M2 or our M20 grade of concrete, and we still want to calculate for this same. So you remember up, if you follow very well, you're going to see that we had the dry volume for this concrete to be 3 meters cube. Okay, now for M20 grade of concrete, the dry volume in 1 meters cube, we have 8 bags of cement. Okay, yes, we have 8 bags of cement in 1 meters cube for M20 grade of concrete. Okay, so it's just pretty straightforward. So if we have that, now the volume that we required up there was 3 meters cube. So if we had 8 bags in 1 meters cube, so in 3 meters cube, we're going to be having what? 8 times 3, which is what? 24 bags. And you see it's still the same. Okay, yeah, so this is also it's very pretty straightforward to do. All you need to do is just calculate the dry volume, cross multiply by 8 bags. So whatever volume you have, you just multiply, and it's so this is the second step. And now for the third step, we go by the density value. Now we got the density value as 0.84 meters cube. And from calculations for M20, we know that in 1 meters cube for M20, for the density values, we have 28.8 bags. Okay, after 28.8 bags of cement, if we're going by the density value. So of course, it's just cross multiplication. So for 0.84, it's just going to be 0.84 times 28.8 bags. And you are going to see that it still gives us 24 point something, boiling down to like 24 bags, which is still the same value that we have up here. So that is it. This is how you accurately calculate the number of bags of cement for any project, okay? So whether you are casting your pillars or your beams or your slabs or any structural member, follow this procedure, you are going to be able to get the accurate number of bags of cement. Point to note is just know the grade of cement that you are working with, the grade of concrete, and you get those values and you calculate them accurately. Okay, thanks for watching. And if you enjoy these videos, always make sure you like and share them, because it also encourages us to produce more videos. Thank you, and see you in the next video.